Hello. So we are doing 10.1 number 4. Now what we've been doing up until this point has been looking at how a car derives its energy from the cylinders in its engine that turn the crankshaft and that turns the wheels. Let's just say I'm better at calculations than I am at drawings. So let's continue, okay? So, our formula for figuring out the energy or the power of a vehicle is this. So the power is equal to the brake mean effective pressure, which I know in some of the notes I have mislabeled that. The brake mean effective pressure times the volume of your engine times the RPMs, the rotations per minute of your engine, how fast the engine's going. If the engine is idling, you're not getting a lot of power, just enough to keep the spark plugs lighting and the radio on. But when you're revving it up, you get a lot more power that helps you go, making the fast moving lines, okay? So, a couple things to point out. Volume is in liters. We need to switch that to cubic meters. This is a lot smaller than a cubic meter, which is literally that by that by that. It's a much bigger space. There's 1,000 liters in a cubic meter, so we have to take that number and divide it by 1,000. Now, something else you need to think about. Your engine, when it cycles, not every cylinder fires every time it cycles. Because remember, it is a 4-stroke engine. There's a downstroke and an upstroke, that's one cycle, a downstroke and another upstroke cycle. So you think of it, there's a suck, squeeze, bang, blow. You only get energy on the 3rd stroke. So your first cycle, suck, squeeze, nothing happens as far as producing energy. The second cycle, bang, that's when you get the energy. So every cycle, only half of your cylinders fire. The other cylinders are parts of the process that doesn't produce power. So since only about half of your cylinders fire every cycle, you need to divide this number by 2 because only half of the cylinders, only half of the volume is doing any work. So divide by 2. And the other thing you got to remember, RPMs are rotations per minute. But power is a function of work done every second. In order to change that you need to change it to rotations per second, which means you divide by 60. So, here you go. It looks complicated. It is, but it works. So, we're going to go down here, power. Now, in my case, the engine had 890,000 pascals of pressure. I know that's not real. I have an electric car. I had to get creative in order to get the numbers to do this. So I've taken some stuff from my van. I've taken some numbers from other places. Most of you guys have numbers well over 1 million. But hey, we're working with it, okay? The volume, also from my van, is a 3.6 liter engine. And my max RPMs from the van is 6,300 rotations per minute. How did I get that? I sat in the van and I looked at the tachometer. The tachometer goes into red at about 6,300 RPMs. So that's a good way to get the number. Divide it by 2. It doesn't matter what kind of car you got. It's going to be a 4-stroke engine. At least in this country, it's going to be. So you divide by 2. If you got a rotary engine. Actually, I'm not sure what to do with a rotary engine. I'm going to have to if you got a rotary engine, please contact me and we'll work on that, okay? Diesel engines, same thing here. You're going to have to divide by 2. And unless you're like riding around in a rider mower, that's going to be the case. Divide by 1,000, liters into square meters, and everybody in the world has 60 seconds in a minute. Now, before you start punching this thing all into a calculator, maybe you look for things to make things simpler. 1,000, 1,000. Take that 0 out, take that 0 out. So we've reduced things. Now it's 89 So, I mean, well, once I've done that, well, that's a simpler equation, isn't it? That looks a lot nicer. So, you multiply them all together. I got power is equal to 89 times 3.6 times 6,300. I got 2,118,520, and 2 times 6 is 12, and that equals a total of 168,210 watts of power. Now, by the way, most of you guys are going to get a larger number than this. The engine here is large, but it's not really large. The pressure, what's going to make the biggest effect. So you're probably going to get a number that's bigger than this, and that's fine. Some of you get a number that's smaller than this. My wife has a Chevy Volt. It actually tells you the kilowatts that it produces, and that thing maxes out about 130,000. So if you get a number that's smaller than this, think about it. If you got a smaller engine, that's a reason you'd get a smaller end number. If you got a smaller car, if you got a bigger car, you can get a bigger number. But the idea is you're going to have something in the hundreds of thousands, in the low 100,000s, and that's probably where you're going to be. But it's kind of amazing that you think about it. You can actually calculate the power of your vehicle based on a little bit of information and a little bit of know-how. And I'll see you soon.